Hi everyone, I'm Ms. Cho, and today we'll find domain and range of a function using interval notation. I like to think about functions as vending machines. They have things inside that you want to get, their snacks, and to get them out you have to push buttons. And every button that you push should only give you one kind of thing. If I hit B2, I should only get these chips. I shouldn't get chips and sometimes Skittles and sometimes Coke. Nope, just one thing. In math vocabulary, functions work the same way. Our domains are all our possible buttons or inputs that we can push to get snacks. For example, in this vending machine, B2 is in our domain because it gives us chips. C4 is in our domain, and then D6. There's a couple others you can list for yourself. But what about B6? Is that in our domain? Well, it's a button, but it doesn't give me any snacks. So no, it's not in the domain. And neither is C0 because that doesn't give us any snacks either. So you can have empty rows in the vending machine, that's allowed, but their domain is all the ones that give you snacks or all the inputs that give you outputs. Our range is all possible outputs. In this case, these are our snacks. So specifically, we can make a list. We have chips, we have cookies, Skittles, M&Ms. Do we have water? No. Do we have Coke? No. You can find them in other vending machines, but not this one. What does this look like in an algebraic context? Well, let's take a look at a function. We have the function y is equal to the square root of x plus 4. So our domain again is all possible inputs. And what do I put into the function? I put in x's. So these are x values. That means as I go along the x-axis, I am asking myself, is this x value in my function? Yes or no? So, at -10, if I go up or down, will I ever hit the graph? No, it is not in our domain. How about at -6? Will I ever hit the graph? No. At -4? Yeah, so -4 is in our domain. And how about at 8? Will I hit the graph? Yep. So 8 is in our domain. And 100, will I hit the graph? Yes, eventually, because I can see that this is increasing, and if I go far enough right, I'll eventually have a graph at the point where the x-coordinate is 100. A shorter way to say this is by looking at, well, what's my minimum x value? I found that x has to be greater than or equal to -4 because after and including -4, everything else on the x-axis will give me a point on the graph. The range is all my possible outputs. And what do I get out of my function? I get out y values. So I can do the same thing going up and down the y-axis and ask, will I hit the graph? So at y equals -4, if I go left or right there, will I ever hit the graph? No, so it's not in our range. What about at 0? If I go left or right at 0, do I eventually hit the graph? Yep, so 0 is in my range. What about at y equals 3? Do I eventually hit the graph? Yes, so 3 is in my range. And if I kept going at, y is equal to 8, then if I go far enough right, I'll eventually hit it. So 8 is also in my range. A shorter way to say this is by asking, well, what's my smallest possible y? And that's 0. And so y, and I know that everything above and including 0 is on the graph. So that is what my range means. We can write about this in inequalities, and we can also use interval notation. So interval notation is just a fancy way of giving a spectrum where you can find possible values. So you have a minimum value separated by a comma from a maximum value, and it's closed in some sort of parentheses situation. They can be curved parentheses, or they can be square. We use curved ones when we talk about greater than or less than. We use square ones when we talk about less than or equal to or greater than or equal to. So in this example, -5 is our minimum value, 8 is our maximum. We notice that this inequality is a less than or equal to, so we include the -5 using the square bracket. But the other one is y is only less than 8. We do not include the 8, so we use a curved bracket. In the second example, which is our domain, that should be a -4. X is between -4 and infinity. We never, ever, ever include infinity, so we always use curved brackets. And then we included the -4 in our example because we saw that -4 gave us a point on the graph. And actually, this is supposed to be our range, which was y is greater than or equal to 0. So in the same way, our y values went from 0 to infinity. We don't include the infinity, and we included the 0 for the square bracket. So I know interval notation is a little confusing. If you have questions, please ask, and we'll see you next time.